Hello everyone, hope you are doing well. Today we'll be talking about another topic from the next chapter, that is your Synchro. Synchro we need to know because we are going to know about the telegraph which is used on board ship for communication, and the rudder angle indicator to indicate at what angle the rudder has moved. Okay, so these two are the application of synchros, and these two are important for exam purpose also, and these are the important systems on board ship, so we need to know about it. Now synchros are basically, what is a synchro? Sometimes in your semester exam they are asking directly the question on synchro. What is a synchro? Explain the working of a synchro with a diagram. So synchro is basically a transducer. You know what is a transducer? Transducer is a device which converts one form of energy into another form of energy. Normally it is non-electrical signal into electrical signal, or non-electrical energy into electrical energy. Okay, now each synchros are in pair. So synchro pair it is called, and a synchro will have two components. One is a transmitter and the other is receiver. So a synchro pair is having a transmitter and a receiver. Okay, and to understand what is a transmitter and receiver, we can just visualize the transmitter in the form of a synchronous motor, and receiver also will visualize in the form of a synchronous motor. So a synchro pair will have we can assume that there are two synchronous motor. Synchronous motor, what is there? You have got the stator winding. So these are the stator winding, and you have got the salient pole rotor. Okay. Now this works on the principle of transformer. How a transformer works? You are giving an input to the primary coil of a transformer. The magnetic field is created, the flux flow through the core, and then the flux, which is of varying magnitude, links with the secondary number of turn and produces a voltage in, or the EMF in, secondary number of turn. So this is transformer action. Now here also we will see, this is the rotor, silent pole, and the silent pole is electromagnet, so we provide a coil onto that, and when we pass a current through the coil, then this silent pole gets magnetized and it emanates the flux. This is the stator. This circular thing is stator, and in that, between the stator winding, you have got the rotors, the salient pole. Okay? And when the flux is created, this flux is distributed in the air gap. What is the air gap? The gap between the rotor and the stator winding. So that's the air gap. So when the flux is created, the flux is distributed in the air gap. Now because of the dumbbell shape, the flux is not uniform. So the flux which is produced in this silent pole is not uniformly distributed because of its shape. Here see, the gap between the stator coil and the rotor is minimum. Now here if I say between this and this is more because the air gap is more, so the flux here will be less, because more is the air gap, more is the leakage flux, so the flux available, useful flux available will be less. Okay, same is the case here, because this stator windings are wound 120 degree 120 electrical degree apart. So this is the angle at which these three coils are 120 degree, these three coils are displaced, and the silent pole, let us say in this position, when the silent pole is, the rotor is vertically up Okay, that means the rotor axis, this is the rotor axis, the rotor XY is the rotor axis. This rotor axis is in line with the R coil axis of the stator winding. Now this axis, this is the rotor axis, and this is the axis of the stator winding, Y axis. So what is the angle between the R axis and the rotor axis? Is 0 because they are in the same line. What is the angle between the Y axis and the rotor coil in this position? The angle between the Y phase and B phase is 120 degree, and this is at the center, vertically up. So this divides 120 into 60 degree and 60 degree. So what is the angle between coil Y with respect to the rotor axis? 60 degree. And what is the angle between the B axis of the stator winding and the rotor axis? Is again 60 degree because this divides 120 degree. So this is Y makes an angle 60 degree with the rotor coil, and B also makes a 60 degree angle with the rotor coil. Have you understood this? Now this is moving, this moves, so, and this is fixed. So we cannot directly provide the current through this. We supply it through a carbon brush and slip it. Okay. So even if it rotates, there is no problem. This is remaining fixed. Okay. Now after you have understood this, now we are going to the synchro. Transformer action we have seen. Okay, let me ask here only. How much voltage will get here? How much voltage will get here? How much voltage will get here? Do we get the same voltage in the 3 coils? No. Since it's a transformer action, the maximum flux links with the number of turns and the impedance of the 3 coils are same. So the amount of flux which links with the coil 1, if the flux is more, the number of turns is same. So here the EMF will be produced more. Now here, because of the air gap is more, leakage is more, so less flux is available here. Less flux links with the same number of turns of the coil. So then here what will happen? The voltage generated will be less. Here also the gap is more, so the voltage generated here will also be less. So the voltage generated in all the 3 stator coils will not be same because of the dumbbell shape of this rotor. Now we will come to the synchro. Synchro, I said it is having a transmitter and receiver, and transmitter you can assume as a synchronous motor. So synchronous motor has got the silent stator winding. So this is the stator winding of the transmitter. Synchro has got a transmitter and receiver. So this is the stator winding of the transmitter, and this is the stator winding of the receiver, and it has got the silent pole. So the silent pole we are representing by its coil, the turns we are winding onto the silent pole. So this silent pole we are representing by the coil here, wound onto the silent pole. So this is representing a silent pole. The winding we are showing here, which is representing the silent pole. This is the receiver silent pole, or the rotor of the receiver. This is the stator of receiver. Now this is connected in the same phase, connected by a pilot cable. So you are connecting 1 to 1 dash. Okay, that is why I have numbered. You also numbered it 1, 2, 3, 1 dash, 2 dash, 3 dash. So you do not make mistake in joining them, connecting them. So 1 has to be connected to 1 dash, 2 is connected to 2 dash, and 3 is connected to 3 dash. So this is how the stator windings are connected. Now we have taken two cases. Case 1, the silent pole rotor axis. This rotor axis is in line with the stator coil 1. This is the stator coil 1. So in this case we will see what is the voltage generated here in the three coils. The voltage generated in this coil will be equal to the voltage generated in each stator coil is equal to maximum voltage Vm into the cosine angle between the rotor axis and the stator axis. So here in coil 1 the rotor axis is same vertical and the stator axis of coil 1 is also vertical. So there is no angle between, the angle between the stator coil and the rotor coil is 0. So what will be the voltage here? The maximum voltage multiplied by the cosine angle between the rotor axis and the stator axis. Rotor and stator axis is 0. So here the cos angle, it will be maximum voltage into cos 0. So cos 0 is 1. So here the voltage induced in this coil 1 will be Vmax, the maximum voltage. What will be the voltage generated in coil 2 in the same position? I am not changing the position of the silent pole. Now in this case what will happen? The maximum voltage, coil 2 maximum voltage multiplied by the cosine angle between the rotor axis, this is the rotor axis, and the stator coil 2 axis. So this is the axis of coil 2. What is the angle? 60 degree. So what will be the voltage in this? Vm into cos 60 degree is root 3 by 2. So the voltage here will be Vm root 3 by 2. Okay. Now what will be the voltage in this coil? The Vmax into cosine angle between the rotor axis and the axis of the stator coil. So the axis of the stator coil with respect to the rotor axis is 60 degree. So here also it will be cos 60 degree is root 3 by 2. So here voltage will be Vm into root 3 by 2. So what is the voltage here? Vm by root 3, Vm root 3 by 2, Vm root 3 by 2. Now in the let us say in your receiver also the rotor is in the vertical position. So same way the voltage will be Vm here, Vm root 3 by 2, Vm root 3 by 2. That means both the stators are at the same potential. So that means when the potential, there is no potential difference, no current flows. When no current flows, current flowing in this is 0. Okay. And this silent pole is supplied through single phase 110 volt supply. So this is getting the supply. So this is magnetized. So it will have the magnetic field. It will have the magnetic field. But force is equal to BIL. I is 0. So the force is 0. Force is acting onto what? Onto the rotor. So the rotor, both the rotors are at the same angle. Now a very interesting phenomena. In your hostel, suppose you have got a transmitter and you change the position of the rotor. So you create an angular displacement. So you create an angle of 30 degree, you rotate this rotor at 30 degree, this is remaining same. Suppose this is placed in one of the classroom in the college building and you are operating from your hostel room. So when you have turned the rotor to 60 degree, okay, then you will find in the classroom also automatically this rotor will turn to 30 degree. How this will happen? The rotor will turn only because of the torque, and the torque is equal to force into distance. So how the force will be created in the rotor which is placed in your college classroom, automatically how it will happen? Now see here, when you have turned the rotor in your room to 30 degree, now what is this is at the same position, vertical position. Okay. What was the position earlier? It is in the same position. So the voltage here is Vm, here it is Vm root 3 by 2, here it is Vm root 3 by 2, but once you have changed here, what is the voltage now? Now the axis has changed to 30 degree. So now the rotor axis is 30 degree with coil 1. So what will be the voltage here? Vm into cos angle between the stator axis and the rotor axis, which is 30 degree. You have changed it to 30 degree. So 30 degree, cos 30 degree is half. So now what is the voltage here? Vm into half. So Vm by 2. What is the voltage here? Now as you have turned this rotor to 30 degree, from here it has turned to 30 degree, means the rotor axis is here. So the angle between this coil 2 and the rotor axis now at 30 degree will be 30 degree here. It was 60 degree and now it has turned to 30 degree. So 30 degree means now the axis, rotor axis and the stator coil 2 axis is 30 degree. So what will be the voltage here? Vm multiplied by cos 30 degree is again half. So voltage in this is Vm by 2. Voltage here is Vm by 2. But what will be the voltage here? Voltage as the axis has turned to 30 degree this side on the right hand side. So and this is 60 degree with reference to the vertical axis. So this axis has shifted to 30 degree. So total angle is 60 plus 30, 90 degree. So the voltage induced in coil 3 will be Vm into cos 90 degree. Cos 90 degree is 0. So the voltage induced in this is 0. Now you see what is the voltage here? Vm by root 3 Vm by 2, root 3 Vm by 2. And what is the voltage here now? Vm by 2, Vm by 2 and 0. So the potentials are not same. So there is a potential difference, and because of that a current will flow in this. Now the force is created because force is equal to BIL. I we are getting, B we are getting from here. This is giving a flux. So flux per unit area is flux density. So BIL, L is the length of the conductor, that is your rotor. So now the force is created because you have moved this, and then this rotor in the classroom in the college building, that will automatically start rotating. Okay, so it will rotate till when it will rotate? It will rotate till it comes to 30 degree. Now at 30 degree, what is the voltage here? Voltage here is Vm by 2, 0. So now in both the stator winding of the transmitter and receiver is same. There is no voltage difference. Both are at same potential. So when there is no potential difference, no current flows. So in F is equal to ILB, I is equal to 0, force is equal to 0, torque is equal to 0. So there is no torque acting onto the classroom silent pole, and it will stop here because anything moves with by the application of force is 0. So it will not move and it will automatically stop at 30 degree with respect to the previous vertical position. So this is your case 2, and this is how it works. Okay. So we will see in the next class the application of this synchro. So in case if it is asked in your semester exam what is synchro, you can write about it, and if it is asked about the telegraph and rudder angle indicator, that we'll discuss in the next lecture. So hope it is clear to you. Thanks for listening.